Alright, and hopefully this one will go a lot faster than number 3, and we can get to those last questions there. So I decided to drain the swimming pool. It's draining 3% every 5 minutes. And so here, let's get X and Y going and get a graph going. So again, I'm going to count every 5 minutes like I did last time because it'll make it a little bit easier than trying to do like 1/5 of 3% and trying to calculate this stuff out. So right at the start, and again, the pool had 1,500 gallons to start out, and then I need to take off 3%. Okay, so if you start with 100% and you take out 3, you're looking at 97% of what you used to have. And so when you're trying to figure out how to get to this next step, you're going to multiply by 0.97 because that's 3% less of what you started with. Okay, and so take 1,500 and times by 0.97, and you're going to get 1,455. And again, we got to times it by 0.97 to get to the next step, which looks like that, and then times it by 0.97 to get to the next step, which is 1,369.0095. Okay, and so that's what you get as you plug in your numbers there. So when you're graphing this, your graph is going to start out like so. I'm just going to count by 5s on my x-axis here. On my y, I'm going to count by 500s. Okay, so my graph's starting out like that. I start at 1,500, then I lose 55 as I go 5 minutes, and so then you go down about 55, not 55, 45, which is down that much, and then down even less as I get to the next part, and even less, well, not up, down a little bit. And so my graph is looking like that, which isn't a very fast decline, but it is going down. Yeah, so it's down. Okay, it's going down. And again, on deciding whether or not it's linear or exponential, remember that you're multiplying by each step, and so it's going to be exponential, even though at this scale it kind of just looks like a linear. A is your starting amount, which was 1,500. We were multiplying by 0.097 each time, so that's going to be the b part, and it goes to the x power. So now we have an equation together. We can figure out these sort of things like how many gallons are left in the pool after 50 minutes. And just now I realized I'm missing a part on my exponent. So it wasn't every minute that we times by 0.97, but it was every 5 minutes. And so with my exponent there, I have to do x divided by 5, because every 5 minutes is when I multiply by 0.97. Okay, so when I'm trying to figure out how many gallons are left in the pool after 50 minutes, I have to plug in 50 for x, and then take that, divide by 5, which gives me 10. So I'm going to do 1,500 times 0.97 to the 10th power, which, if I calculate, is going to give me, one second, times by 1,500. Remember, do exponential part first. That's going to give me 1,106.0 136 gallons. Okay, and then the next one, about how many minutes will it take to have less than 1,000 gallons in the pool. Well, if this is how long, if it took 50 minutes to go that far, we probably need to go another 10, maybe 20 minutes. So let's try that out. Plug in an extra 20 minutes, which would be 1,500 times 0.97 to the 70 divided by 5. So do 70 divided by 5, and then you gotta do 97 to that power, 0.97 to that power. And then you gotta times it by 1,500. And that actually gets you to 979.25 gallons. So that's a little much. 70 is too much. We could change it to be 65. And when you do that, you're going to get, let me fix my calculation real quick. 65 divided by 5, 0.97 times that, and you times by 1,500. There you go. You're gonna get 1,009.54. And so this is going to be between 65 and 70 minutes. I'm going to say 70 minutes, because when I plug that in, I got less than 1,000. And there we go. Now it's time to answer the last questions there, 5, 6, and 7. Compare problems 1 and 3. What similarities do you see? What differences do you notice? So as I go to 1 and 3, I notice 1 is putting in money into the account. You're adding each time. It's linear. 3, also getting money in the account. But this one's exponential. So both of them increasing the money, and it's one of them's adding 3 cents each day. The other one's adding 3% of the $50, and that one's actually growing a lot more. Anyway, compare problems 1 and 2. So 1, again, is the piggy bank, adding 3 cents a day. 2 is adding 2 gallons every 5 minutes. Both of these are linear. I'd say those are the similarities. Differences are that the number 2 has a different slope, that's for certain. It has 2 fifths rather than 3, which is what it is for number 1. Compare problems 3 and 4. What similarities do we see? So here with 3 and 4, they're both exponential because I'm multiplying by a number each step. They're different because on 3, I'm increasing my values. On 4, they're decreasing. So those would be major similarities and differences between the problems.